Imagine standing outside, far from city lights on a clear, dark night. The air is crisp, and a gentle breeze whispers around you. Look up. Way up. Let your eyes adjust to the darkness. You see the moon, a familiar beacon in the night. Maybe a bright planet like Venus shimmering with reflected sunlight. But let's zoom out, far beyond our familiar celestial neighbors. Let's embark on a cosmic journey of epic proportions. Earth shrinks to a marble, a pale blue dot drifting past Mars, the rusty red planet, and Jupiter's swirling storms, a giant ball of gas with its iconic Great Red Spot. We are leaving our planetary neighborhood behind. Our solar system, with all its planets and asteroids, becomes just one star among billions in the Milky Way, our galactic home. Each star a sun, potentially with its own planets, its own stories. The galaxy itself, a vast spiral of light and dust, fades to a speck, joining a cluster of galaxies. The local group, a collection of galaxies bound together by gravity, all moving through space together. Even this cluster is just a thread, a tiny strand, in the immense Laniakea supercluster, a gravitational behemoth stretching across hundreds of millions of light-years, galaxies upon galaxies, all connected in a vast cosmic dance. We're now so far that sunlight traveling at the fastest speed possible hasn't reached this point and never will. The distances are so vast, so incomprehensible that light itself is dwarfed. Clusters blur into points, merging into a grand tapestry, forming a shimmering cosmic web, a network of galaxies and dark matter stretching across the universe. As we look further across these immense distances, we look back in time, seeing galaxies as they were billions of years ago, when the universe was young and still forming. We are witnessing the universe's history unfold before our eyes. Finally, we reach a limit, a boundary, the edge of the observable universe. This is as far as we can see, given the age of the universe and the speed of light. This isn't a wall of matter, a physical barrier, but a wall of time, the faint afterglow of the Big Bang, the cosmic microwave background, the oldest light in the universe, stretched and cooled by billions of years of expansion. It's the universe's baby picture, a snapshot from when it was just 380,000 years old, a time when the universe was a hot, dense plasma. We've reached the horizon of our vision, the limit of what we can currently observe. But what lies beyond? What lies beyond this horizon? What is the true nature of the cosmos, beyond our current understanding? Are there other universes, other realities, waiting to be discovered? Our journey of cosmic exploration has only just begun. The universe is vast, mysterious, and full of infinite possibilities. The quest to understand it continues. So, what is this universe we've just zoomed through? In short, it's everything. Space, time, matter, and energy. Every galaxy, star, planet, atom, and ray of light is part of it. There's nothing outside the universe, it's the totality of existence. Our best science says the universe had a beginning, the Big Bang, about 13.8 billion years ago. It wasn't an explosion in space, but an explosion of space itself. From that moment, space and time began expanding, and they still are. As the universe cooled, particles formed atoms, then stars and galaxies. Everything we see today is a product of this cosmic evolution. We are literally made of stardust, forged in ancient stars. The expansion continues, not galaxies flying apart, but space itself stretching. Imagine dots on a balloon. As the balloon inflates, the dots move apart because the surface expands. This is our dynamic, ever-changing cosmos. The universe is not static, it's alive with motion. When scientists talk about the universe, they often specify the observable universe. It's important to make this distinction because our understanding is inherently limited by what we can detect. This refers to the portion of the cosmos that we can, in principle, observe from Earth. It includes all the galaxies, stars, nebulae, and other celestial objects whose light has had time to reach us since the Big Bang. Visualize it as a sphere with us, the observers, at its very center. The radius of this sphere is defined by the maximum distance that light has been able to travel to us since the Big Bang occurred billions of years ago. Now here's where it gets interesting, because the universe isn't static, it's constantly expanding. This expansion has a profound effect on the size of the observable universe, making it significantly larger than what a simple calculation based on the age of the universe might suggest. The observable universe is much larger than 13.8 billion light-years. In fact, due to the expansion, the current estimated radius of the observable universe is approximately 46.5 billion light-years. This vast distance highlights just how much the universe has expanded since the light we're now observing was first emitted. To grasp this concept, imagine a messenger running toward us across a road. But this isn't just any road, it's a road that's constantly stretching and expanding as the messenger runs. The point where the messenger started, which was already incredibly far away, is now even more distant due to the continuous expansion of the space between us. This boundary, often referred to as the cosmic horizon, isn't a physical barrier that you could bump into. Instead, it represents a fundamental limit imposed by time and the speed of light. And here's another mind-bending aspect. The observable universe isn't the same for everyone. Every observer, regardless of their location in the cosmos, has their own unique observable universe. Imagine an alien civilization residing in a distant galaxy. They would be at the center of their own observable universe, seeing a different portion of the cosmos than we do. What lies beyond our observable universe? Current scientific understanding suggests that the universe is likely far, far larger than what we can currently detect, and it may even be infinite. Think of it like a sailor standing on the deck of a ship. Their view is limited by the horizon, the farthest point they can see. But the ocean extends far beyond that horizon, stretching into the unknown. The true size and nature of the universe remain one of the greatest mysteries in science. What we observe is just a small patch, a glimpse into a much grander and potentially infinite reality. Imagine embarking on a journey to the very edge of our observable universe, a voyage to the cosmic horizon. What wonders, or perhaps what nothingness, would we find awaiting us there? What would it even mean to reach the end of everything we can see? It's not a physical barrier, not a wall of rock or energy. Instead, it's a boundary in time, a limit to how far back we can see, defined by the age of the universe itself, the afterglow of the Big Bang. But what about the universe beyond what we can observe? Does the universe have an edge at all? The answer, surprisingly, is that the universe may not have an edge at all, at least not in the way we typically imagine. When we consider the overall structure of the cosmos, there are two main possibilities that scientists consider. The first is that it could be infinite, stretching forever in all directions, an endless cosmic ocean teeming with galaxies beyond our current perception. The other possibility is that the universe is finite but without boundaries, a concept that can be a little harder to grasp. If the universe is indeed infinite, then you could theoretically travel forever, constantly encountering new galaxies, new structures, and new mysteries. Our observable universe, with all its billions of galaxies, would be just a tiny, insignificant bubble in this endless expanse. If it's finite, imagine the surface of a balloon, a finite area, meaning it has a limited size, but no edge where you can fall off. On the surface of a sphere, if you walk far enough in one direction, you will eventually return to your starting point, without ever encountering a boundary. The universe, in this scenario, could be like this in 3 dimensions, a closed, curved space, often visualized as a hypersphere, where traveling far enough in one direction would bring you back to where you began. Our measurements, particularly those of the cosmic microwave background, suggest that the universe is remarkably close to being geometrically flat, but we can't definitively rule out the possibility of a slight curvature, which would imply a finite, boundaryless universe. So, whether the universe is infinite and flat or finite and curved, there's no edge in the conventional sense, no cosmic cliff waiting at the end of space. The cosmos, as far as we can tell, is either endlessly expanding into the unknown, or somehow loops back on itself in a way that defies our everyday intuition. Ultimately, the idea of an edge is a human intuition, a concept rooted in our experience of living on surfaces with edges and boundaries, and not necessarily a reflection of cosmic reality. If the universe extends beyond what we can see, it opens the door to the multiverse, other universes, each with their own laws and histories. One idea comes from eternal inflation. The Big Bang wasn't unique, but one of countless bubble universes forming in a vast cosmic foam. String theory suggests extra dimensions where our universe is a brain floating in higher dimensional space with other brains, other universes nearby but invisible. These ideas are speculative, born from advanced mathematics, not direct evidence. The multiverse remains a tantalizing possibility, hinting that our universe may be just one grain of sand on an infinite beach. It's a humbling, awe-inspiring thought. The true scope of reality may be far stranger than we imagine. Even within our own universe, the edge of what we can see is unreachable. The boundary of the observable universe is a horizon in time, not a place. The galaxies at this edge are now over 46 billion light-years away, receding faster than light due to cosmic expansion. Nothing can travel through space faster than light, but space itself can expand at any speed. Beyond a certain distance, galaxies are carried away so quickly their light will never reach us. Even a spaceship at light speed could never catch up. The frontier is fundamentally unreachable, always receding. Over time, more galaxies will slip beyond our horizon, vanishing from view. In the far future, only our local group of galaxies will remain visible. The evidence of the Big Bang and the cosmic web will fade, leaving future astronomers in cosmic isolation. The universe's vastness will become even more mysterious. We've zoomed out from our tiny world to the grandest scales, exploring the universe's birth, expansion, and mysterious boundaries. The more we learn, the more we realize how much remains unknown. Science gives us a powerful story, but the biggest questions remain: what is the universe's fate? What are dark matter and dark energy? Are we alone, or part of a multiverse? We stand at the edge of knowledge, humbled by the mysteries ahead. The universe's edge is not a place but a boundary of understanding. That's the wonder of science. There are always new discoveries to make. The quest for knowledge never ends. As you look up at the night sky, ask yourself, what lies beyond the furthest thing we can see? The universe invites us to keep exploring, to keep wondering.